So Faris, you normally go jogging?
At evening, not morning.
Can't hear you.
Jogging dia.
Jogging.
At the evening and sometimes night.
Can't hear you. Tak clear. Can you repeat?
I usually jogging at the evening and sometimes I do at night.
Do you jog alone or with friends?
With my friend and sometimes alone.
With female friend or male friend?
Mix.
Mix. Now let's keluarkan hukum agama pula sekarang. Is it allowed to jog with mixed friends?
I not jog like apa? Just plan together and start the same and we jog at our own pace lah. Lepas tu end together like cooling down.
What do you think? How does Islam see that? Is it allowable, Faris? You think? Without just stick. Tell me what you think. If allow, what's your dalil? Tak dengar?
Don't know.
I can't hear you.
I don't know whether.
Alright. Sometimes I see, brothers and sisters, sometimes they play volleyball at the women's sports complex. I can see them playing there. Sometimes I can see they playing on the women's sports complex, and sometimes at the tennis court. They're playing, I don't know what, volleyball, something like that. Now I want to ask all of you, what do you think? Is it allowable or not in Islam? I want you to think. I don't want to tell you. I want you to think. So sometimes we do things without really thinking. Anybody? No problem, right? Islam, what do you think?
I think it's not allowed.
I can't hear you.
It's not allowed in Islam.
It is not allowed. Why?
Because like the woman for you, it's not halal. Just not you're not a brother, you're not a husband, just like this. So it's not halal for you to go with her in somewhere like this.
So that's Islam. Ustaz Islam has already spoken. Let's hear ada Ustaz or Ustazah. Ustazah Kamalia, what do you think? All IIM student Ustazah, yes or no? So Ustazah Kamalia, what do you think?
It's not allowable.
It's allowed? It's allowed? Huh?
Not.
Allah teruknya internet awak.
No. Saya tulis sama tu. Can I write?
Yeah, sure, you can write. Let's ask Ustaz Rahimi lah. Dia mufti from Kelantan here. What do you think?
Not allowed.
Why not allowed?
Because create
Why? We are not doing anything, right, Faris? We are not like holding hands also. Faris katalah, ataupun orang lain kat situ kata. We are not like, so why not? Why cannot, Rahimi?
Because it's law. We cannot have girlfriend, and to avert from that,
She's not my girlfriend. Orang tu kata lah, she's not
friend
my girlfriend. We just play together. We just do sports together. Rahimi. Ready?
I don't know.
Allah, suddenly don't know. Kena asak sikit pun ni ustaz ni lah. Alright, Afrido, what do you think?
Ma'am, I think it's not allowed because of non-mahram thing. But there's a question arises in my mind. If that's not allowed, then how come we're doing classes together? Like in our kuliya, in our class, there's girls and boys together. How come that is halal then?
Very good question, Afridul. Let's ask Ustaz Ahmad. Okay, Ahmad, what do you think? Ustazah sekalian, get ready. Yes.
Personally, there are conditions like you can interact with the opposite sex when there is, like, for example, if they need help or something, if there's something that requires, like, not out of the blue, you just go and talk to them, you know. Also, seeking knowledge is something, you know, important. Like doing something for the sake of Allah together is not in my opinion, I'm not an alim, but I feel like it's not wrong.
Apa?
You
Can
know?
you repeat the last sentence?
Seeking knowledge for the sake of Allah, like for example, like what Afridul said in class, why do we are mixed together? Well, we're learning, you know, we're learning about, for example, about science, Islam, whatever it is.
How about sport now?
Sport is a tricky one.
Tricky, okay, why?
I don't know, I've never done sports with women before, but in my high school we used to have this road run. It was mixed. It was like we didn't start together, but we were, you know, jogging together along the way. But I don't know, I don't know, like I don't know if it's haram or halal. I don't know what, like, the ruling on that.
All right, thank you, Brother Ahmad. Any sister want to say, or the other brothers? We only have like 2 more brothers and 2 more sisters. Ikram. Alah, awak ni kalau suruh volunteer, nobody want to volunteer. Ikram, what do you think? Tell the truth, but nothing but the truth.
I think it is not allowed in Islam.
Why?
Because we as a Muslim need to take care of our ikhtilat.
What is ikhtilat?
Sana cakap Inggeris.
Tak tahu awak yang sebut.
Saya Google yang ada.
Awak apa?
Google ya.
Google. Okay lah, while Ikram is googling, ni tak tanya apa Ustaz Aiman lagi. Tak apalah, kita reserve for next time, Ustaz. So okay, it's interesting. You know, now sometimes, you know, nowadays, that's why Rasulullah SAW said in the end of time, during our time is actually nearing the end of time, where Rasul said to hold to Islam, to follow exactly what Islam says, is like holding a coal, you know, arang betul apa perkataan tu, arang batu macam bara api, to hold a coal, you know COAL, a coal which is burning. So if you cannot hold it, it's so difficult to hold it unless you are very strong to hold it, otherwise you will let it go because it's hurting you, right? And that is our state now. In the end of time, it's not easy because everything everywhere, everybody are doing it. All the things around us are like pushing us to do this, and we have to be strong not to do it, because this is the world that we live in. It's not like everybody are nice. That's even in International Islamic University Malaysia. Can you imagine if it's not an Islamic university, what more can happen, right? Okay, the reason I'm telling this, I think it's important because one day you go out from IIU, even in IIUM, you will see people do certain things, and without thinking, you will follow. Even worse out there, there are many other things that the other outside people do. For example, when I was during this like program under the Ministry of Higher Education of Malaysia, an Islamic university, Islamic country, so-called. So the Ministry of Higher Education had a program for like a specific program for, they call it CEO at faculty. CEO at faculty, where faculty members, those who have PhD like me, age of less than 40 years old, they want to groom future leaders of the lecturers. So they have this program. What they did was, it's like they have to go through interviews and boot camps as a selection before they are, only selected people will go to the final stage to the industry, where they will be attached to a CEO. Okay, so in my batch, 300 plus lecturers, all with PhD across Malaysia, age of less than 40 applied, and only 50 managed to pass through. So it's not easy to pass this thing. And among there are like 3 boot camps. We have to go like stay somewhere. And lastly, there was in like a military boot camp. It's like the one, in military, they have all these obstacle, things like that. Can you imagine? I have to go through that. And the reason being, if you go through that, the objective of the program is by attaching ourselves to the CEO, we will learn leadership and management, which I don't have the knowledge. If I want to teach you leadership, right? Islam, Ahmad, I want you to become a leader, and I don't know how to become a leader. How can I teach you, right? So that's why it's not compulsory. I choose to go because I want to learn, so that I can learn from the best. So hopefully I can transfer the knowledge to my student. That's my intention. So that's why I go. So this program is for all Malaysian, meaning there's a Chinese, Indian, and Malay, but majority are Malay. Only like, I think like 80% are Malay there, 20% Chinese and Indian. So one of the programs in the training was they have this they group team, they grouping, like they want to assess your leadership, your teamwork. So they have this leadership, they has this no, I'm recording this. Okay. BJT lah. Alright, so Bipolar junction transistor. Okay. Story 9/11. So, brothers and sisters, there are 2 main transistors, main category of transistors, which you already learned in your first year. Number 1 is what we call the bipolar junction transistor, BJTs. And the other one is the field effect transistors, FETs, or MOSFET. We will be learning a specific of FET, which is MOSFET, later on, inshallah. So first, now is on the BJT. So a typical transistor, we have all transistor, we have 3 terminals, okay? 3 terminals, but the name depends on the BJT or FET, because although both of them are transistors, but how they work are really different. The mechanism, how it works is really different. So that's why the name is different, because the way it's turning on and off and amplifying is different. So the physics, when I say how it works, the physics are different. So in analog circuit, okay, analog circuit, right? You have digital and analog. Digital 10 10 10 10. Analog is something like it has variation. It's not discrete, it's continuous. So in analog circuit, transistor can be used as amplifiers and linear regulated power supply. You can use a power supply, but most of the transistors are used as amplifiers. So you can increase, for example, amplifier like your speaker is a type of amplifier. A certain your voice, low voice, and you increase amplifier, becomes you increase the voice. So you change from sound energy to electrical current. In digital circuit, transistor, the same transistor can also be used as switches. As I mentioned before, PN junction normally we use as switches, but transistor can also be used as switches, where they use the switch normally in logic gates, right? This is what all our electronics are based off of logic gates, random access memory and microprocessors. The VLSI, the integrated chip, mostly are using transistors. Okay. Now, okay. Now, the question is, why BJT is called bipolar junction transistor? There's a junction there, the BJT bipolar junction transistor. Junction stands for, because PN junction is a junction. So we understand if you bipolar junction transistor, there's a junction, that's why it's a junction transistor. Why is it called bipolar? Anybody knows? No? Okay, so why it called bipolar? Bipolar because the way we have two transistors, right? We have MOSFET and we have BJT. So the main difference of the two transistors is one of the main difference is, for MOSFET, there's only one type of carrier which is important. The current is due to only one carrier. It's either electron or hole for MOSFET. The current that flows in a MOSFET is either electron or hole. It cannot have two carriers at one time. That's for MOSFET. That's why in your first year, when you do your calculation, if you remember the calculation for electronics, the calculation is much easier for MOSFET because it's the physics are not so difficult. There's only one type of carrier. However, in BJT, the name is bipolar. Bi means two, because the current is due to the two carriers. So current in BJT are due to electron and hole. So you will see later on the maths and the physics are a bit more complicated. Okay, the mathematics will be a bit more complicated. Why? Because there are two carriers inside the bipolar junction transistor. Okay, so that's the name, a bipolar, because the one that that contributes to the currents are both electron and holes. So field in effect transistor normally sometimes called unipolar transistor because it depends primarily on one single carrier type, whether it's electron or hole. And this is a revision. You already learned this before in your first year. So BJT, you have PN junction that are joined back to back. So we learned before PN junction, we have PN over here, PN. So if you draw the PN back to back, you can draw a diode like this. So basically BJT, you just put the transistor, the diode back to back, and you got a transistor. You just combine these two, become a transistor. So a BJT, you have two types. You have NPN transistor and you have PNP transistor, depending on how you arrange the PN junction. So if in the middle is the P, you get NPN. If in the middle is the N, you have PNP. So how does that make any difference? We'll go through, you will know, you will understand when we go through how it works. Okay, it makes there's a difference if you put it NPN or PNP, and here are the symbols that you already learned before. The arrow shows going out is the NPN, going in is the PNP. And there are three terminal over here. You have the collector, you have the base, and you have the emitter. Okay, so that's the terminal for BJT. For MOSFET, there are three terminals as well, but it's called differently. So modern, this is a discrete transistor. Discrete means sketul lah, one piece of transistor. Basically, you can see three legs coming out. If there's a three legs, you know it's a transistor. If it's two-legged, you know it's a diode. So you can buy this in the shop. So this is the discrete, but the one in the, you have also bipolar junction transistor in a IC, integrated chip. So it'll be very small. It won't be like this. This one, although it looks big, although this one look big, you can hold it with your hand, but the actual semiconductor wafer or die or chip inside is actually very small. Only the packaging is big. The packaging is big so that it's easy for you to handle, but inside, actually the semiconductor BJT transistor is actually very small. Okay, the same as goes for the diode LED also. For LED, for example, you can hold the LED, but the actual semiconductor inside is very, very small. Why? Oh, that's a good question. Why? Anybody knows why? Why is it very small, the semiconductor piece device inside? I'm drinking, cinnamon water. They say it's good for the health. All right, it's not, that doesn't taste very nice, huh? Why?
Reduce the cost.
Apa, Ikram?
Reduce the cost.
Exactly. Thank you, Ikram. So, we engineers, we try to reduce costs everywhere. That's how we work in life. Even in life, when you are trained as an engineer to always reduce costs. When you in life, for example, you want to go shopping, also you were thinking what is the most cost effective to go from your house to balik kampung, for example. We are trained to be like that. Engineers are trained to always do the most cost effective. So the cost effective and reduce cost as much as possible, because in the end engineers want to sell. We sell whatever we do. So a piece of semiconductor wafer maybe looks like this. It's round. Okay, maybe this is 3-inch. So you can make one single transistor or PN junction out of this single wafer. You can make it still work. Or what you can do, you can make all the PN junction or the transistor here, but you cut into smaller pieces, as small as possible, and for each one you put contact, front and back. Okay, so what the engineers do is they cut the wafer into smaller pieces, as small as possible. As small as they can cut it, and as small as the piece can work as a device. And therefore, this, instead of selling one, they can sell maybe 10,000 diodes out of this one single wafer. Okay, so therefore you get like 1,000, 10,000, profit. So that's all. The packaging is big because packaging is cheap. You don't need high technology, it's just plastic. Okay. All right. So now you know. Okay, now we talk about fabrication. Okay. What is fabrication? That's a good question. Anybody know what is a fabrication? Anybody here takes VLSI design? Is taking, Ikram, patutlah Ikram tahu. Okay, only Ikram? VLSI design, anybody else? No? Faris. Oh, Faris.
I took it as well.
Huh? Apa? Hana?
I took it as well. Sorry, my internet is so slow right now.
So you are taking it now?
Yeah,
or?
I can take it. Yeah.
Okay, what is fabrication? No. Faris, Hana, or Ikram?
Pretty sure it's when you manufacture it.
Do you understand, Aiman?
No, I don't understand.
Okay. Can the
It's when
VLSI explain, huh?
It's when you manufacture the semiconductor device. So
They still don't understand, sister. You need to elaborate. Other people, if want to help, I mean, from the VLSI, because if you cannot explain this, I will call Prof. Anis. See, Prof. Anis, they don't even know fabrication. Then what are you teaching? Dia mesti mengamuk. So, so I know Prof. Anis. You're very passionate in teaching. Yes, come on. What is fabrication? Ikram, Faris. Hey, janganlah senyap. Oh, tahu ke tak tahu ni? Ikram.
Process of manufacturing the BJT.
Dengar. Okay. Kemas, saya tak
Process of manufacturing the BJT.
Do you understand, Aiman?
It's similar to grow of the semiconductor.
Oh, jangan tutup mulut, orang tak faham. You know, one of communication, when you speak, if I speak, I keep on closing my mouth like this. You know, can you understand what I'm saying? No, right? Sebab the way we learn on communication is we see how the mouth moves. Lagi-lagi kalau internet tak okay lagi, kita akan tengok mulut tu macam mana gerak. So Ikram again, what is fabrication?
Is a process of manufacturing the BJT, similar like to the growth of semiconductor, I guess.
Aiman?
I think I understand a bit.
Okay, you tell me what you understand.
The process where the BJT was manufactured, same like in semiconductor, they have growth of semiconductor, right? So that's what I understand from Ikram point.
Is that correct, Faris?
Yes.
Oh,
Yes.
Correct. Okay. Okay. Fabrication, kadang-kadang, okay, I will tell you the confusion with the word fabrication. Kalau dalam IC design, even IC design, fabrication means including the growth of the semiconductor device or integrated chip. Dia semua, including doping, everything that is still called fabrication in a IC design industry. So if you go to the working in Intel or in Infineon, Motorola, Texas Instruments, so this when I say fabrication, what they meant is everything including the growth. Okay, but I'm just telling you, just to confuse you more, when you go in if you go to a research environment, for example, you go to work for your PhD also, normally we separated the growth and fabrication. Growth is growing the layer. Fabrication is when we etch, we make it into individual device. Growth is the growth of the epi layer, in the epitaxial layer. Setiap satu line yang kuih lapis tu, kuih lapis that's what we call growth. Fabrication is when we cut it. When we cut the semiconductor, kuih lapis, and then we put the contact metal top bottom, that's what we call fabrication normally. So but I will use the general term that the industry is using, which is fabrication means everything. Okay, so you say you fabricate the diode, it means that you grow the diode, you cut the diode, you put contact to diode, and then you packaging something else. They don't call packaging including in the fabrication. No, packaging is another. They call it downstream, whereby they have another factory doing just only the packaging. Okay, so that's fabrication. So now you know what's fabrication, huh? So when you make the bipolar junction transistor, you can make it into discrete devices or planar integrated form. When I say discrete devices, is this the one that I show you just now, single one? Or you can make into integrated chip. You can put it next to a resistor, next to a diode in one integrated chip. So ni tak yalah. Saya kasih benda yang tak confusing, all three concepts on top surface. Okay, so how does it look like? What is the Quayla paste for a BJT? It looks like this. See, can you see? So yeah, although if you look at the the schematic, it looks like this, NPN like this. You think that you will put it next to each other, but no, when we actually building it, it doesn't look like that. It looks like this. So there are three terminals: the emitter, the base, and the collector. Okay, so how does it work? Yeah, should I draw this? Okay, I will draw. Just to show you how it works. So okay. Okay, BJT. So now it's similar to kuih lapis again. You have to imagine kuih lapis. But okay, now maybe not so much of kuih lapis. Now we're doing marble cake. I know you don't like cooking, you don't know about cooking, but I love cooking. One of my hobby is baking. I like to bake anything. So like my mother also love baking, so I follow her. So marble cake, if you go and watch a video on how they do marble cake, normally they will have a base and then they will put on the other flavors to make it look like a marble. Okay, so this is side angle, side view of the marble cake. So what happens is, number one, they will make the so we have three. We have the collector. Okay, the highest doping will be the emitter. Okay. Normally, what they do is they will make this, the whole thing here is with a certain doping. You remember kan, BJT is like, let's say this is NPN. So you have N, you have P, you have N. Okay, and then you have the three terminals. You have the emitter, base, and collector. That's your BJT. So this is how you draw it schematically. But in terms of the real thing, it will look like this. So how they make, they manufacture or they fabricate. Number one, first they do the collector first. So a collector, for example, they dope the yellow here. I dope it maybe with. So here the collector is N-type. Okay, N-type. So I will dope this maybe 1 × 10⁻23 per centimeter cube of the N of the donor atom. Okay, the whole thing first, make it N, and then what happens next? Then they will make the base. So they will add another, they will add another doping. So they will dope it to become another color, blue. So they dope it. So they will dope it to a P with a high doping. When I remember if I told in the class before, if you add P and N doping in one, there will be compensation, doping compensation, whereby in the end there's only, it depends on which one is higher, it becomes P or N. So if you dope this higher, if you dope the base here higher, then this become P. So it can become 10 per minus 23 centimeter cube of P. Okay, so they make the base. So after they make the base, okay, so you have the base. Now they need to make the collector. So the emitter. So later on they dope it again with N, but only for certain region. So then maybe become 1. Maybe this is more 24. And okay, so if you look here, so therefore you have, then you make the contact. You make the metal contact. You have the base, you have the emitter, you have the collector terminal. So this is the same as this. Okay, so that's how they make the this is the normal basic BJT. Nowadays, if you go and Google and read journal papers, they are no longer like this. It's more complicated. Why? Because they want to improve the efficiency. But basically, it's like this. Okay, so let's go back to my slide. My drawing is slightly different than the drawing here. Okay. So basically you have the NPN over here, but the highest doping, normally you want to dope the emitter with the highest doping. You will understand why later when we talk about how the physics of it. So normally that's why on the top is always the emitter, right? And then the base and then the collector. So why we need to dope the emitter the highest, and you can easier to control the doping when you dope the device. It's easier to control the doping when you put the highest doping at the top instead of the emitter at the bottom here. Okay, so it's more about practical, how to do it, not the physics much on the practical, because engineers, physics, sometimes they just know on the theory and they don't know how to make it. They just know the theory. We engineer, we need to know the physics, the theory, and plus practically how to do it. So that's why normally engineers still recording have a higher salary, because we not only have to do, and we have to do better than a physicist. We need to know the physics, and plus we need to know how to make it in real world, to make it happen. Okay, so this is the engineers will be thinking about, oh, now we need to put the highest doping at the top. Now, so if you look, so the one that I draw was there until the mid-60s. Nowadays it's more complicated. If you look, this is the cross section of a BJT nowadays. It's a bit more complicated. Why? Because there are problems with the basic one. They want to improve the performance, so they design a better design. So whereby there's a base, two side of the emitter over here, they make it two contact and collector. So similar, it's still similar, except for the base they make two side. You will know why later. We'll talk about this. Okay, and then you have the collector, and then this side and silicon dioxide, SiO2. This is silicon dioxide, is a insulator. So isolated between each device is the insulator, which is silicon dioxide. Okay. Yang ni kenapa dia letak to improve the performance of the transistor, nak reduce leakage current and so. Okay, so ini tak payah go through lah. In BRSI design, I don't know whether you cover fabrication in terms of how you do it, how you dope it and everything. In this class, I don't cover as well. You can, if you want, you can go and Google how actually you do, what is etching. Etching is basically to remove, you etch away. So there are specific and physics and equipment to do this etching. There are many types of etching, and one of it is plasma etching. This is just for you to know. I will not ask you in the exam or quiz. Okay, just so that you know. So I will not cover oxide and trench isolation. Now how does it work? Okay. I should do a video on this so that I don't have to repeat myself. Anybody know how it works? No? Let's draw. So when I'm drawing, I'm expecting you know how to draw in the quiz or exam. Okay, so whenever I draw, it means if I can draw, you should be able to draw. Kalau tok guru boleh buat, kenapa anak murid tak boleh buat? So if a teacher draws, it's expected that the students also draw. Okay. Now, saya rasa tak tahu kita sempat tak within this time. Let's do preliminary first. Okay, this is a BJT. So let's say this is NPN. So you have 3 terminals. So this is NPN. And you have the 3 terminal, which is the emitter, base, and collector. It's always base in the middle. Okay, now, okay. Normally, what we'll do is the base here is always smaller as compared to the emitter and the collector. For example, the way I draw it like this, right? So you can draw it like this. You don't draw, so the base should always be smaller. I will tell you why later. I will explain you why. But when you draw this in the exam also, make sure your the base is smaller as compared to emitter and collector. So this is not a mistake. I purposely make it smaller, and you have to also purposely make it smaller. Right. So, okay, now. Okay, now do you remember how a PN junction works? So if you can see here, this is one PN junction. And this another one, this is another PN junction. I hope nobody colorblind here. So basically what you have here is PN junction back to back. Because this is P, this is N. And then you have P again, N here. Okay, so that's why it's PN junction back to back. Now, question. Okay, now anybody can tell me what happens now? What happens at zero bias? Because you understand how PN junction work, right? So let's talk about zero bias. What happens now when you put the NPN together like this?
Diffusion.
Hai Sarah.
Diffusion.
Diffusion. Apa yang diffuse? Janganlah bagi satu perkataan. You tell me the whole what? Give me the whole sentence.
Electron from N diffuse to P, while holes from P diffuse to N.
Okay, what else? So how about this on this side? How about this side?
Same thing happens to the to that side.
Okay, so next what happened?
And then recombination, and then and it will form depletion region. Also at the both sides.
Okay, good, very good. So basically, what happens at PN junction? It happens here. So you have diffusion, you have recombination, you have depletion region, you have a drift off, then you have built-in voltage, then you have drift current. So then everything will be in equilibrium. So in the end, what you get is a depletion region, right? So here. Okay, you have depletion region. Okay, this is zero bias. Okay, now I forgot. So in bipolar junction transistor, there are different types of mode of operation. If you look in the slide here, you can use it in the bias mode. You can use it in forward active mode. Saturation mode and cut off mode. You learn this in your first year electronics. We can bias the BJT ni to be in normally three main mode: saturation mode, active mode, cut off mode. Okay, so now let's look at what this one. You have to remember this table. Make sure you remember because you already learned in first year. So cut off mode is when you reverse. Okay, let's see what happens when you reverse. Okay, now when they say EB junction, this is base to emitter junction over here, and then this is collector base to collector junction. There are two junction. There are dua diode here. So in order for it to be in saturation mode, both of the PN junction need to be forward biased. For it to be in forward active mode, you forward bias the base to emitter junction here, and you reverse bias the base to collector junction here. Then if you do that, you entering the forward active mode. The cut off mode is when you reverse bias the base to emitter junction, and you also reverse bias the base to and you reverse bias the base to collector junction. Okay, so there are three modes depending on how you bias the transistor. Now let's look at how it works. So what happens exactly when you do this? Now let's say okay, this is zero bias. Zero bias, nothing happened. You have depletion region, everybody happy, all carriers happy. So now I'm let's say I want to do it. Next is I want to do it to become cut off mode. Cut off mode. What will happen? Cut off mode, base to emitter junction, you reverse, and then base to collector junction, you reverse. Okay, anybody can tell me what will happen here? So saya kata you need to understand PN junction, otherwise BJT you be in trouble. You need to be very comfortable with PN junction. What happens here now, Aiman?
Yes.
What happens here ni kat sini? What happens?
The depletion region become wider.
Okay, which side?
I think both sides.
Okay, good. So what happens is the depletion region become bigger. So remember, if this like this. So if you reverse bias this and reverse bias this, is there any current that will flow with a bigger depletion region here? Will there be any current that will be flowing, Aiman?
No.
No. That's why cut off mode means there's zero, there's no current. So whenever you really want to you don't want any current to move, to flow, like a switch, you want to off it, you want to off the switch, you need to, you cannot leave it like hanging, you need to make it cut off mode. You reverse bias this junction and you reverse bias this junction, then definitely there's no current flowing. Okay, good. Now,
Madam.
Yeah.
Is it include with the leakage current?
No leakage current you will still have leakage current. So in reverse, you still have current, right? Very small. Yes or no, Aiman?
Yes, very small.
Yeah, you have but very small. So, but that's the best. You cannot. There's no perfect off. There'll be a slight leakage. That's why if your handphone, right? Where's my handphone? If your handphone, right, you don't use it, you just leave it around anywhere. After some while, it will drain your battery. The reason why there always be leakage current, so we still consume a little bit of energy, voltage. So that's why we cannot make a battery that lasts forever, because semua electronics ni dia ada leakage. Okay, but our job as an engineer is to reduce the leakage as much as possible. Okay. Next question. So we understand cut-off mode means you have like bigger depletion region. Then next is we have saturation mode. Saturation mode is when base to emitter junction you do what? And then base to collector junction you do what? You forward the base to emitter junction, and base to collector junction you also forward. Okay, this is saturation mode. So you forward both diode. You forward both of here. So what will happen to the PN junction over here? It means that you reduce the depletion region because it's forward bias, right? So then apa nama ni? So the thing is you forward both lah. So this is P. So current will be flowing from P to N like this, and current will be flowing through that, both sides of current. But normally saturation mode we don't normally use. Normally saturation mode, if you remember in your first year, saturation mode, if you want to have a space, normally use it for like digital 1010. It's not use it for amplifier, which is not. In our class semiconductor device, we will concentrate more on the amplifying of a transistor. So which means that the third mode is the most important, which is the forward mode, forward active mode. So the forward active mode, the base to emitter junction, you forward bias, and the base to collector junction, you reverse bias. Okay. So what will happen here? So you forward bias the base to emitter junction, means the depletion region is very small, and then you make it reverse bias the base to collector junction. Okay, this is the forward active mode. and the time's up. In next class, inshallah, we'll learn how the BJT works, especially for the forward active mode. I will talk about where the electron will flow. Okay, I think that's enough for today. Inshallah, don't forget to work on your assignment. If you have any question, you can text me, because after the break, you need to present, right? Okay. Any question before we end?
Passwords?
Okay, thank you. The password for today is Faris. Can you help us with the password? Suggest the password.
BJT.
Okay, so the password of today will be BJT. Thank you. Let's end with a doa. Can we have somebody to recite a doa, please? Whose turn is it today?
I will read.
Okay, Kram.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. اللهم إنا نسألك الإسلامة في الدين وعافية في الجسد وزيادة في العلم وبركة في الرزق وتوبة قبل الموت ورحمة عند المغفرة بعد الموت. اللهم هلنا في السكرات ونجاة من النار وآخرة الحساب. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين. آمين.
Alhamdulillah Rabbil Alameen. Thank you, brother, for the dua. Let's end today's class with tasbih kifara and surat al-Asr. Subhanakallahumma wa bihamdika nashhadu an la ilaha illa anta nastaghfiruka wa natubu ilayk. Bismillahirrahmanirrahim. Wal 'asr innal insana lafi khusr illa allazina amanu wa 'amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, enjoy your mid-sem break. Don't enjoy too much. You're in your final year. I think you should work very hard before you have a good rest when you finish your degree. Now is the time to like all out for your study. Okay, that's all. See you in 2 weeks' time. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you,
Thank
madam.
you.